In this video, we're going to learn how to write the equation of the normal line tangent to a function at an x value. So in our first example, we're trying to write the equation of the normal line tangent to the function x squared minus 3x at the value x equals 1. So in order to write that equation, we're going to need a slope and a point. If I want to find the point first, I'm simply going to plug in my x value into my function. So notice I'm going to replace all of my x's with a 1. I get 1 squared minus 3 times 1. That would be 1 minus 3, which is negative 2. So I now have a point 1 comma negative 2 to use. Now in order to get the equation of the normal line, I should first find the slope of the line tangent to the curve, which would be the derivative 2x minus 3. Let's plug in that 1. So we get 2 times 1 minus 3, which is negative 1. Now this is the slope tangent to. To get the slope of the normal, we would take the negative reciprocal of that slope. So the negative reciprocal of negative 1, think of that as negative 1 over 1. Let's flip it upside down and change the sign. So our slope of the normal would be a positive 1. So now that I have a point and a slope, I can plug into point slope form. Y minus y1 equals slope x minus x1, giving us y plus 2 is equal to 1 times x minus 1. Generally, this is a fine answer. Sometimes they'll distribute and turn it into another form. We could think of that as y plus 2 is simply x minus 1. They could write it as y equals mx plus b by subtracting the 2, which would give us y equals x minus 3. Or they could write it in general form. If they wrote it in general form, if we subtract the y to bring it over with the x, and then add the 1, we could get 3 is equal to x minus y, or x minus y is 3. So we need to have good Algebra 1 skills to convert to different forms. In our second example, again, it's write the equation of the normal. If I want to get a y value first for my point, f of pi 6 is equal to sine of pi 6 squared. Notice I rewrote that, thinking of it in this form to make things easier. Sine of pi 6 is 1/2, and when you square 1/2, you get 1/4. So our point is pi 6 comma 1/4. Now let's take the derivative to find the slope of the tangent line. So the derivative would be chain rule, derivative of the outside, don't change the inside, multiply by the derivative of the inside, which would be cosine x. We now want to plug in our x value of pi 6 for every x. So we get 2 times sine of pi 6 times cosine of pi 6. Well, that would be 2 multiplied by sine of pi 6 is 1/2, multiplied by cosine of pi 6, radical 3, over 2 is f prime of pi 6. Well, clearly we can cross out the 2's, leaving us with a slope of the tangent line of radical 3 over 2. Now, the normal means we want to take the negative reciprocal of that. Well, the negative reciprocal of radical 3 over 2 would be negative 2 over radical 3. Now that we have a slope of negative 2 over radical 3, Let's put that into point slope form again. Y minus y1 equals mx minus x1. That would give us y minus 1/4 equal to negative 2 over root 3 times x minus pi 6. There are a myriad of options for alternate examples. One thing that might occur is they might rationalize this value. So remember, to rationalize something in the denominator, we would multiply by root 3 top and bottom. This would give us an alternate slope of negative 2 root 3 over root 3. So we could have y minus 1/4 is equal to negative 2 root 3 over 3 x minus pi 6. Again, you should be well versed in rewriting this value in y equals mx plus b form or ax plus by equals c form. In our third example, again, the equation for the normal line tangent to the curve. So let's find our y value first. F of 1 is equal to the natural log of, we're replacing x with 1 everywhere, so 4, 1 squared plus 1 would be the natural log of 5. And we're going to go ahead and leave that as natural log of 5. We're not going to do anything with that. Now we need to find the slope of the tangent line, which would be the derivative. Derivative is a chain rule. There's an inside function. So the derivative of natural log is 1 over something. Don't change the something, which is the inside function. Multiply by the derivative of the inside, which is 8x plus 1. So now that I've got a derivative of 8x plus 1 over 4x squared plus x, let's again plug in that 1. So on the top we would have 8 times 1 plus 1 over 4, 1 squared plus 1. 8 plus 1 is 9. On the bottom, 1 squared is 1 times 4 plus 1 is 5. That's the slope of the tangent line. So the negative reciprocal of that would be a negative 5/9. That's our slope, negative 5/9. Again, let's plug that into point slope form, giving us y minus the natural log of 5 equal to negative 5/9 times x minus 1.